Welcome to Never Rewrite. I'm Isaac Askew.
And I'm Jeffrey Sherman, and today we're joined by Nick Gerace to talk about a rewrite that went well. So, Nick, you're part of the System Initiatives crew. We've been interviewing pretty much everyone, uh, which is awesome. So,
hmm
you're the first Nick that we interviewed a few weeks ago. He mentioned that there was an engine rewrite and that it went well. And you're here to tell us about how awesome it was and how everything went perfectly.
Yeah. Well, that's totally how it goes every time, right?
Yes.
Yeah. So I guess a little bit about myself. I'm Nick. I've been at System Initiative since December 2021. I'm the second engineer in the company, fifth person overall, and we've seen a lot throughout this process, and
Mm-hmm.
the company's been growing and scaling, and it's been great. But
For people
along the
who
way,
didn't
Mhm.
watch all of the previous
Sure.
episodes, which can you tell the audience what System Initiatives does?
Yeah, that'd be an important thing to do. We are uh, essentially a supercharger. I like to think of it as a power tool for people managing and deploying their infrastructure. So you can sort of envision System Initiative as a replacement to Terraform or Pulumi, but even something way more than that. It's specifically a platform that has digital twin functionality, high fidelity models, as well as a hypergraph of functions that run. So if you need to qualify a piece of your infrastructure, take in desired state from your model or take an actual state from the real world, all that kind of stuff in order to see everything uh, across your data center or cloud
Mm.
platform and be able to manage it and make it all behave in a way that's compliant and effective configuration. So that's sort of like an overall vision of System Initiative. It's on one hand the user interface, but it's on another hand this sort of core engine bit, which funnily enough we're going to talk about today, I think.
Awesome. All right, so let's get into it. So, over the last few years, you've rewritten the original core engine from the original to the new.
Yeah.
Well, were those the names? Because I have a theory that if it was called New Engine, it was going to be doomed.
Yes. We actually have a rule that you can't name projects Phoenix because they
Yeah.
rarely rise from the ashes. It actually wasn't planned as a new engine at first. I mean, the scope was that large, but it wasn't called new engine. So to give you a bit of a recap, it's 2023 and we're in the summertime and we're trying to prepare some of our work that will get us towards an open source launch so people can try the System Initiative software themselves. And we need the ability for users to customize assets, or what we call them in System Initiative. So write their
Mhm.
own functions and be able to contribute and share them. You can think of it like in some video games, you can share like modifications you made to the game online and download it and share them amongst users, or any other kinds of extensions to this core system. And we didn't have a way to tell the lineage or total lifespan and life cycle of what's a module, like these
Okay.
essential extensions and changes you make to the core system. So we then took out, pen, pad, paper, and we said, wait. Before we even start doing this opportunity to have users share their creations with one another, how in the world are we going to be able to version these things, get them installed, and overlay them on one another? And what if you changed it and I changed it? And are we just going to
Mhm.
reinvent Git? And like, what is happening here?
Package management is hard.
Yeah, it is. And what we ended up realizing is, amongst a host of many other issues we were having with the existing system, we needed something that looked like a directed acyclic graph, and you could think of the modules as being their own directed acyclic graphs that went up to the index. And then what happens when you like perform the equivalent to a git rebase from one graph to one graph, and then the merge thing in the end is what's in the user's workspace. And that's really what kicked it off. I can dive into more, but that's sort of like a little teaser into how we got started. I think at this point it's like June or July 2023. And I guess I should give you the terminating point. March 2024, the old engine was so it was not meeting our expectations for performance because we dog food our own product, and if we're unsatisfied and can't use it, then we have to fix that before we continue to sell. And from March 2024, we actually, before the new engine was fully just feature flag it on, we hard switched over, and we're in a period of like in betweenness from March 2024 to May 2024 about. I think it was like May 15th we finished it. So it was about, 6 months end to end. The specific starting and terminating points are a little fuzzy because it was emergent. And then in the end, is there really a point where it's all done, or is it like good enough, right? So yeah, that's like a overall timeline on what happened.
Cool. So to summarize, you started off with, hey, we're embracing the open source community, and we realize we need this package management functionality, and that you don't support it at all. And then as you build that package management functionality in, it becomes clear that the original engine isn't going to work or isn't working. Could you have upgraded, like were the performance fixes part of like things that came in through packages, or were they things that you could have done independently? Like if you had known that you were going to do a rewrite, instead of backing into it, could you have just done those performance rewrites or changes over a few months and not done the package management?
So here's what's interesting is that the performance benefit was emergent. We didn't know how big that was going to be until later. I mean, we had inklings. So to give you more of like the technical bits in lieu of answering your question, or on the way to rather.
Yeah, I love technical bits.
So basically the directed acyclic graph is all in Rust. So all of that happens in memory. The traversals, the mutations, the modifications, the accessors, all of that happens in memory. And the old engine was a relational database, basically. It's still, the new engine actually runs on top of Postgres. There was a period in time where we were evaluating all kinds of stuff, including DynamoDB and single table design and all this crazy stuff. But essentially, when we went to the graph section of what we were doing, we said, okay, well, all of these complex stored procedures and functions and queries, they would actually move to in-memory. So this constant back and forth between a Rust modeled object to a database query to a Rust modeled object to a database query, and all these hops were sort of eliminated. And then we realized the performance benefits were on the table. And the performance was bad. I consider it bad. Maybe it it wasn't what we needed in summer 2023, but it is worth noting that we were really pushing the product harder and harder as 2023 went on. We were building more and more on top of it. We were taking it to its limits. So would we have had the foresight to say, should we take on the performance fixes and, the module stuff? Could we have fixed in a small way and done it independently? Perhaps. And actually, I want to say it was October, September, November 2023. My sort of, for lack of better words, co-designer of this new engine, Jacob, he actually went to try and perform some performance fixes and left me for a bit on the new engine project, and bought us a lot of time, basically put more, actually, this is kind of funny. The old engine moved more into the database and out of the Rust because of all the tables were in Postgres. Doing all the back and forth at the Rust layer was actually ineffective and slowing us down. So more of the store procedures worked in such a way so system initiative is a hypergraph of functions, right? So how a lot of things in system initiative works is hey, where do I get my data from? I'm a Kubernetes CRD and I need to fill in some data for this field. Okay, I need to get it from this Docker image object. And this Docker image object says, hey, I have this port 8080 and this ports array. Where did this get populated? Oh, it got populated from a function that ran on our security group and networking setup. And this sort of daisy chain effect happens where in the database and in Rust land and old engine, it would constantly ping pong back and forth. So at the Rust layer, we would say, okay, I'm processing this current field of this object. Let me go run a bunch of database queries to figure out the function I need to run. And then the function runs and it stores its result in the database. So Jacob actually, in order to do some performance fixes while the new engine was going on, moved more of that to the database so that inside you'd say, okay, I'm processing this field. Well, maybe there's a function that I need to execute before setting myself. So let me go to this other table, execute a query in here. And it was just a bunch of stored procedures. And it bought us some time, but we found that ceiling pretty quickly.
Right. So it sounds like the original system it was keeping all of its state in the database, but it wasn't doing any of the business logic in the database. And so the short-term performance improvement was to move more of the business logic into the database, so you had less of the back and forth.
Yes. And we did actually have a lot of it in the database, but it was just even more of it. And one little inkling in the back of my head that I was thinking about was, we are the bus factor of number of people that understand these stored procedures, because they were really complex, was exactly 1. Oof. And, the second Jacob would go on vacation or even someone that knew a specific element of the system, it was pretty difficult to tell how to fix it. With Rust, the big benefit is while we don't hire specifically for people knowing Rust, like we have not historically at all, of course, it's a big benefit. And when we ask people to do the take-home assignment, it's in Rust as well for our positions in the past. What's the big benefit is that there's a lot more compile time checks than runtime checks. So even if you haven't seen a lot of the code base before, you can sort of break something and the compiler will tell you, hey, you broke this other thing over there. Whereas with our stored procedures, we were really reliant on integration tests. And because it was more live action, so to speak, like I changed something over here, the system runs and it affects something over there. And of course, that's true for Rust as well, but especially so for Postgres. So there was actually, now just talking about it out loud, not only did we move more to business logic to the database and it bought us some time, but there was this inkling of this is going to feel pretty difficult to maintain. So I think at least for me, there was already some seeding that the new engine was providing more and more benefits as we were writing it in ways that I don't think all of us actually realized.
That makes sense. Yeah, like just as from the 10,000 feet, if you say, "Oh, I'm moving my business logic into the data into my persistence layer for performance," I'd be like, "Okay, well, you know why you're doing it, but it's a bad idea. It's going to bite you."
Yep. And we still actually use Postgres. It's just we use it as purely a persistent storage layer. So so think of it this way, right? So if you have a directed acyclic graph of everything in your workspace that you can do in System Initiative, and you can even apply this to any application you're writing where you have like this sort of daisy chain effect or hypergraph of functions, you're not going to store an entire massive object. Like I presume you both have used Kubernetes before, or at least somewhat familiar with it. So think of like a config map and someone stores like a 1 megabyte object in a config map, and then etcd falls over and we all start sobbing. Yes, I worked at Rancher Labs and saw a lot of Kubernetes stuff blow up. but we're not storing all those big objects on the graph. The graph basically are minimally sized nodes for the minimal information we need to traverse it. And then we pull out, we extrapolate that information. So for the given ID, basically, go fetch me in the content addressable store And it's content addressable because, if you have multiple objects that are the same thing, like Docker image Nginx would be a contrived example. We don't need to store that 3,000 times. We'll store it once. And so when we traverse the graph, we call out to the content addressable store. That's done in Postgres. It's like a very simple 2-column type table. It's not really taking advantage of the relational bits, although there are actually a few things we do in that domain. And then the snapshots themselves, we're calling them snapshots of your graph at a point in time. Those are also stored in Postgres. So we haven't ejected Postgres out of the mix. We just actually, ironically, as the performance fixes, as you were saying, moved to the business layer, the persistence layer, that business logic, we actually pulled it all out for the new engine.
Yeah.
So it was the opposite direction while we were working on it the other way, which was kind of a funny thing to happen.
Yeah, as you say, when you move your business logic into the database, it becomes unmaintainable.
Yes.
I've seen that many times. Well, not many times, but at least a few times where it's like, oh, we're just going to move this over there.
Yep.
Although I guess that's how Oracle worked. But that's
a lot of
80s
money
and
to be
90s.
made there from Oracle. It's actually funny. In throughout this whole process, while there were times, and this is true for whether it's Oracle or Postgres or whatever, while there were times where we thought we might move to DynamoDB, single table design, all the kinds of things on the table. In fact, System Initiative, its oldest piece of infrastructure, probably even older than Postgres, is NATS, which we use to communicate between all the services. We use both its durable message queue layer called Jetstream, as well as its fan out style of communication. The core NATS is what we've been calling it for communication bits. And we were like, hey, can we actually persist some things in these NATS Jetstream store? They even have a key value store. We make use of some of that stuff, but there's something about these databases that are just so rock solid that we've just that with Postgres.
So you had how much of the new engine was new? Because you mentioned you had the old engine, and the reason that you ended up backing into a full rewrite was, hey, it wasn't performant, and you were solving the add-on problem. I'm just wondering, did you end up having to do a full was it the same language? Were you able to reuse large chunks of it, or was it wholly new? And like when you had that straddle period, were they mostly the same?
This is actually where things get pretty interesting. We had a specific goal to not touch two services in particular, and it was the front end experience, which is very core to System Initiative. And of course, we had to tweak certain bits because not everything translated one-to-one. But I was looking at a design doc here from July 11th, 2023, getting into this. And it says, TLDR, if we do this correctly, it should be invisible to the user. And what that means from a developer programming interface perspective is at the API server level, which we call SDF, which is from a show called Robotech that Adam likes. I forget what SDF stands for.
Super Dimensional Fortress.
Yes. That is our... now I remember what it stands for. SDF, we basically said, what if everything sent over the wire was untouched? So what that made it very easy for... And we went in a direction already where the integration tests look very similar to the API routes in a lot of ways. So when it came to like the test assertions and the return routes from the API, we kept them as stable as we possibly could. So that was sort of a big guiding light in order to not collapse on ourselves, because here's one thing that's interesting that I tell a lot of newer engineers or folks looking for advice in rewrite situations. So there's sort of this like myth, and some of it's kind of true, more fact than fiction, that developers sort of yearn for this day where it's like, if I just had 3 months, I would rewrite everything and it would be perfect and no one bother me and no meetings and I leave the office and come back. And to some extent, there's truth in that, but you have to tie it to the business or your organization's goals. So the new engine was literally a catalyst or was literally authorized because we could not move forward without it as a company to accomplish the goals we needed. We still did time boxing. We still set out goals. Everything at our company either has a budget or a deadline. There is no such thing as unbounded time because work expands to the scope and bounds of your time. So this was a 6-month endeavor, but when we chunked it up into little bits, we actually spiked and workshopped them as we went along. And we learned some lessons along the way. In the beginning, it was a little more unbounded time because we have a process at System Initiative called Discovery, where we say, we need to figure out what we need to do to fit everything in a business opportunity canvas. And I know this is the Never Rewrite podcast, probably a little more engineering oriented and engineers talking about gnarly bits. But the fact of the matter is,
we let you go on about graphs. So yeah, it seems to be a sign.
Yeah. But the fact of the matter is that none of it matters if I'm not going to have a job next month because we collapsed on ourselves and couldn't get funding because the engine didn't work, right? And that is really the big context here. So yes, we rewrote System Initiative's core engine and new engine. And now to more get back to the core of your question, it was still in Rust, way less SQL though. So that was a major change. Like you barely have to touch SQL anymore if you work at System Initiative. I haven't in months. Or it might have even been in 2024 was the last time. It's been a while. I added the audit logging system and that required a little bit of SQL, but even then that was very, very small. So that was a major change, all coming back to Rust. Way easier for other folks to make changes. Typically our director of product or VP of engineering, they'll make PRs all the time just because everything's a lot more revealing to them in order to do what they do. And when it came into the breakages and where to go next, so I'm sorry, I have so much to say about this topic. I'm trying to be focused. But when it came to the interfaces themselves and breaking one another and did we port everything, we are big believers in domain-driven design. It is the most transformative book I've ever read was the original domain-driven design book. I think by Chris Evans. I'm looking over here if that's who wrote it. Yes, Evans. I think his first name's Chris. Anyway, domain-driven design.
Link in the show notes.
Yeah. That book was absolutely transformative in my career and core to what we do at System Initiative. So rather than littering the code base with like util files or laying it out in such a way that it's written to the programming interface, it's actually separated by domain using bounded context and ubiquitous language between each domain and one another, such that most of the files were not renamed. Most of the interfaces that you use to call into those integration tests I was telling you about, those API routes, remain the same. Get me this, so a System Initiative concept of a piece of infrastructure as a component. Get me this component by its name. Did not change. Update this property field for a Docker image port array. Did not change. And that sort of helped us bound everything. So I give you a few answers here. The scope of the business, you can't just infinitely rewrite the world. Sort of a guiding rule that this should be invisible to the user. And it was moving things from like 60% Postgres, 40% Rust to 95% Rust, 5% Postgres and SQL. So yeah, a lot of stuff in there, but that sort of, I think, more than answers your question, I think.
I think so. So I want to shift focus. I'm now curious. What you mentioned, there was a cutover period of a few months where you started off, you hard coded that it was to use the new engine, and then I guess you eventually shut off the old engine. Does that mean that you had like 6 months of work that was ready to go, and then it was all boom, we put in the hard code to switch over? Or was the new work for the new engine, like the package manager and all that, coming out incrementally for the whole 6 months, and then it was the final piece?
We wrote that. That's a great question. We had a branch that we were merging PRs and commits into over and over. And that branch was not on main. It was a separate branch for 6 months. And we had no form of forward or backwards compatibility with it. You had to run it yourself. And it was basically two projects happening in parallel. When it hit, I think it was March 2023, late February 2023. It was around that time when we had the moment where we could not build our own infrastructure with the old engine because it was too slow. We then said, well, rather than having 3 engineers work on the new engine and 8 engineers work on the old engine, we were going to call no more feature development on main, basically. Like halt, stop, pull the production line, like literally wholesale stop. If someone wanted something tomorrow, unless if it was a quick bug fix or a side quest to unblock someone trying out System Initiative, we did not work on it. We said it was better for the survival of the business to basically take what wasn't 100% finished and merge that PR into main, make sure the code compiles, but comment out any test that doesn't pass. And literally be in a half-broken state for 2 months. So now at this point, feature development on main ceases. The new engine branch, which how we got that name, by the way, we record weekly demos. We now publish them on YouTube, but we used to not to. I think one day I was watching a lot of Formula One at the time. I like cars. So I've always thought of this as like, the invisible to the user thing. I'm like, we're basically doing an engine swap from like a V8 to like a supercharged V8 or whatever. And we're just lifting it and putting a new thing in. So that's where that wording came from. And I still remember the day. You could probably find the PR. The branch was called New Dash Engine. We got it compiling. We got it mostly working. We merged it. And then all 11 of us swarmed to say, here's the old interfaces. Here's the front end UI. Let's restore it. And that's basically the work we took on for an additional 2 months.
So it's like, I'm just going back and summarizing in my head so I got it right. So you had you're doing the package management, and then you learn as you were going along, you discovered that you had this giant performance problem, and you decided to cut the cord and like, okay, it's just going to be a rewrite. We're going to move forward. And after about 6 months, you hit this forcing function of you can't use your own software anymore.
That's right.
And so then you merge it in and you decide to deploy it to production for yourself. And it's not that it's a disaster because you know what you're getting into, but you do a freeze of feature development on the original product. You merge in your code, and then you spend 2 months using it to get it going, and then into production for everybody else.
Yeah, that's precisely right. I'm happy that that came through. But the only little thing is I think we stopped deploys because there wasn't really a point in using a product that you could like half use. So I think we actually kept the old branch sort of still. I can't remember if we backported fixes or not, or if we had like a side branch that's like little fixes. I don't think we did. I think we just poured everything in. It's worth mentioning too. I should have looked this up beforehand because I can't remember. I think we actually assigned a deadline to getting that sort of 2 month effort. I think it was a 6-week deadline, if I recall, to feature parity. And the difference between deadlines and budgets at System Initiative, because like I said, you're either in one or the other when you work here. Budgets are, because work expands to the time allotted, budgets can be broken, right? Like you set a budget for, so I'm wedding planning right now. That budget's going to be broken. Right? Budgets can't be broken. Like that house renovation you did, or that vacation, or like that PC build, or like whatever you're doing, it might go over. It also keeps you honest, and it keeps you choosing the right things and dropping things from scope. Deadlines are, in a way, a more extreme version of that. So there were some things parity wise that I don't think we got it to 100% parity. I think 90% parity, 95, some features turned off at the fringes, and then we turned it back on. So what is the fastest way we can start using this for ourselves again was a clear mission. It wasn't really this unbounded, like we need literally every single thing to work as it did or better. And in fact, there was performance left on the table. It wasn't necessarily faster at first, because that's the other thing too, right? You can be this one thing, a careful trap in engineering. I could tell you all day, oh, we're working on the graph. It's in memory and it's easier and it's not at the persistence layer and there isn't this back and forth. And then you end up realizing that you accidentally wrote it in such a way that it needs to recompute the whole world every time a user makes a change. And I see this happen a lot with development. So you need that time to refine after. So we were very clear with our goal for the new engine at parity. Performance will probably get there. A lot of this we need to do in post. And we actually just kept refining it over the next year and over time. That's a tangent in and of itself. But the one thing I want to make clear was it wasn't this like end of May comes and it's like, oh, it's perfect and it's way faster. It was like, no, now we unlocked ourselves to make these sort of lineage package management stuff. And we did get some performance benefits immediately, but we now know, okay, we're in a point where we can build on ourselves and sell ourselves again, but the work is still ongoing. So having very clear goals and being explicit with one another with what the goal, with what the plan was and the work we were doing was brutally important. When I say to you, we rewrote the new engine in 6 months, it wasn't developer paradise. Don't bother me. I came back and it's in the newest programming language and it's perfect. No, it was very clear goals throughout with time box work.
Yeah, some things that I think that stand out for this story versus some other stories we've had. The Khan Academy story was they had a forcing function as well. They were an old version of Python that was not going to be supported by, I guess, I forget, it was like Google's.
I think it was Google.
Some host they had. So they were forced to upgrade. And they kept the language the same too, just like you did with Rust. It wasn't a complete language swap, which is kind of a disaster. Also, you had test coverage. Most other stories we hear, like the test coverage is very poor, and there's not a very good understanding of the old system. So it's more of a rewrite because this doesn't make sense. Whereas your integration tests painted the picture of how it was supposed to behave, even if you did comment out a couple just to get it in there for that last merge into main. But those two things stand out. And you a couple of times you mentioned like this was more of a survival of the business thing, which kind of echoes again the old Khan Academy story of we literally have to do this. Like this is what's forcing it, rather than a nice to have or kind of a more of a wish thing. It was very much aligned with business goals. So those things are the initial things that pop out as well, whenever we hear all the old failed rewrite stories versus the ones that are succeeding, if we're going to call them, we have our own kind of distinct definition of rewrites in this world.
Sure.
That's one of the ones, as we advise people like to go this route versus that route, these are slowly kind of, I think we're finding a common theme here. What were you going to say, Jeffrey?
Yeah, well, the part that really perked my ears up is because I was, 3/4 of the way through, you merge back to main, and then you were iteratively going for it. And I think I saw this video. And that was important. And also, you were able to go forward with not full feature parity, which is one of those things that kills you, is that last 10% of feature parity. It's almost a Pareto of, it's 80-20, and so that last 20% is going to be 80% of the work.
Yep.
And you were able to bust through it, and you're just like, screw it, we're just not doing it. We're willing to take the hit of not having it and working through it.
The best thing you can do as an engineer is that I recommend to a lot of folks that I meet for one-on-ones or like whatever. If you contextualize your job into the scope of the business and organization that you're in, you know, so let's talk about that 10% we left on the cutting room floor. 3 people were using them. So am I gonna delay this deadline by like a week, or not delay a deadline? We don't do that. But what gets caught off the floor? A feature no one's using? Absolutely, and we'll bring it back. We'll bring it back for that user. We need to. But can we go through the core loop?
You knew how many people were using which features. Like you had observability. I think is one of the. You had the test. You had the observability, or did you not? You were just kind of it's like, yeah, we think it's like 3 people.
A mixture of both. I mean, we use post-hog and some other forms of telemetry, open telemetry. Like we can tell how many times a route has been hit. Post-hog, you can look at some of its user metrics. We weren't really using it as much at that time, but we did a bit. So we can sort of get equivalent to like a heat map, so to speak. But the other is we're very high touch with our early customers. So we're in Discord with them. We talk to them all the time. We're constantly iterating with them, and we'll just be quiet and watch them and see where they struggle and see what they like. We do a bunch of user testing. So I think it was a little column A, a little column B. I wouldn't call this purely data driven though. I don't want to oversell that, but yeah, there was a little bit of that we knew, but it was mostly the high touch element that let us know, okay, what are people actually using right now?
Right. I guess that's a good point. When you're early days, there's not much difference between data and anecdotes.
Yep. You have to be careful though. There's iconoclastic design, which is famous engineer goes to a lab and builds the software they've always wanted to build. And they come up out of the ground after 3 years and they show up and it's super opinionated and perfect. And then there's super product driven. We user test frequently. We rebuild it. And if they don't like it, I don't even care if that's what I believed in my whole life. Yeah, there's a little bit of that iconoclasm and sort of like that. I need that core design or art to stick, but I'm going to rewrite it all not this podcast version or rewrite, but like I'm going to like rewrite the little fiddly bits to make the user experience journey better. And the point I was making with this is that that quicker feedback loop, that high touch loop to iterate on the product through user testing, that really informed a lot of what we did. And the problem with the iconoclastic design is unless you are building for yourself, you have a habit of getting high off your own supply with the anecdotes. So anecdotes are really important in early stage, but
for sure,
separating which ones are your own from which one are your users and finding that happy medium, I think makes for a great product experience.
That is awesome. Totally agree. Oh wow. Should we leave it here? Because we've been going long.
Yeah, I'm sorry. That's my fault. I just love this topic.
No, I don't need to apologize because this was a great story. And it's really helping me. Like we're in the process currently of writing a book on all this because we've got so many different guests and different just different perspectives of what fails and what succeeds and what we're the book is so far the title is like the rewrite trap, and this here's the easy things you can fall into that will make you fail, and then here's the perfect alignment of things that might help you succeed. And we see like again like we're teasing out some common themes for these cases where there's some successes, and they are very rare. We see a lot more failures than successes. I think we've got 2 successes, and even then again like we're trying to tease out what we're considering a rewrite. But this one's closer to the rewrite because it has like 2 systems working in parallel. There was a feature freeze on the old one, which generally speaking, that doesn't happen.
Things.
So we have a whole list going. So either way, this has added a ton of color, and this has been one of the more entertaining stories, I think, that we kind of need as far as like our noodling on what works and what doesn't.
Yeah, stories I think are such an effective way. Brian Cantrell from Joyent and Oxide Computer uses the word like oral tradition in software. Like I think more campfire type storytelling I think is effective because it is an emotional experience. And if you notice, I tie a lot of it back to the business and like my job and why are we here. because that's, I think, what really informs the journey and prevents like this sort of like dream world type, I'm just going to rewrite it so it's easier to use. And yeah, we did that along the way. Of course it became easier to use and write. And of course, like that little engineer in the back of my brain with unbounded time, like had some great moments to do that stuff, but it wasn't the guiding principle. And the one last thing I'll say, because I know this has gone a little long, is my very first job was at NetApp, and that code base for Waffle, the Write Anywhere file layout system, they sell storage, if you're unfamiliar with them, storage devices, and a bunch of other cloud storage software. They're a great company. There was C code in there from 1993 and Perl code from the early 2000s. And I started there in 2019, 2018, that time frame. So there are some things that will never be rewritten there intentionally, and tying it to the scope of the business. The things that aren't rewritten, probably the cash cow software. So some other day we could probably talk, maybe offline. I'd be happy to talk about the book, but I did kind of use some like knowledge of the past. There's some things you simply like just should not take on in the way we took on this project.
Yeah.
Yeah.
We ran into that too.
Thank you so much for coming on. If people want to get in touch with you or learn more about you, where should they go?
Yeah. For me, go to nickgerace.dev. That's NickGerace.dev. It's links to all my socials. I don't know what's going on with X, Twitter, Blue Sky anymore. Just, you can find me somewhere. And then as far as like, what we do at System Initiative, you could go to systeminit.com and join us on Discord. Honestly, even if there isn't like a, hey, I liked what you were all saying, I just want to talk more about it, or tell me more about this, show me PRs, show me the product, all of it. Just go to that website, find us in Discord, and come talk to us.
Awesome. Thank you so much, Nick. I'm Jeffrey Sherman.
And I'm Isaac Askew, and this is Never Rewrite.